You're getting a look now at the station's robotic arm using the multi-dexterous manipulator as it works to change out some of the tools and get ready to move through the operations for today. And then joining me on console right now, we have one of our robotics operators from the Goddard Space Flight Center, who's been involved hand in hand with controllers here in Mission Control Houston as they move through to do some of these checkouts. So his name is Alex Janas. And Alex, thank you very much for joining me here today.
Thanks for having me here.
Why don't you tell us a little bit about what you do up at Goddard and how you got there?
Pleasure. So at Goddard, I'm one of the robot operators for the Satellite Servicing Capabilities Project. The project as a whole is working on using robotics to practice servicing satellites as we've ramped down a lot of manned spaceflight work. My job there is I work on the robotic test bed. Obviously here we're doing flight robotics. There we're testing everything on the ground before we can send it up to orbit. So what I've done there is we design tools that interface with non-cooperative satellite interfaces, that being the satellites in orbit right now aren't designed to be interfaced with robotics. It's a very non-friendly interface. There's lots of wires and valves and covers. So we work with the tool designers to design the tools, and my job is to throw them on our robots, which are actually industrial robots, but we've used custom software to mimic flight robots. And we take them and we test out the tools and we provide feedback, and the idea is to have the best product possible when we send it up in flight.
Okay, very cool. And as we've been talking about a little bit through this hour, they are working on the Robotic Refueling Mission, which is a payload that was flown up last July in the final shuttle mission. So we actually have an animation that's going to go over some of the more general points of that payload. And why don't we talk a little bit about that now?
Sure thing. So what you're looking at here is the SPDM, Special Purpose Dexterous Manipulator, and it's accessing that big box there is RRM, the Robotic Refueling Mission. It's on one of the ELC carriers. And there's 4 different tools on RRM itself. RRM is kind of a self-contained test bed here. We have 4 tools that we can pull out, and we use those tools to interface with about half of the interfaces are our custom designed interfaces that have tools and adapters. Like here you see the multifunction tool pulling out an adapter that removes tertiary caps. And then once it pulls out this adapter, it'll access what's called a fill drain valve, and these valves are very common on satellite interfaces. And these are the interfaces that you have to remove these caps and ties in order to actually access the refueling port where you can transfer fluid to refuel satellites. So here it's removed the tertiary cap, and it's now stowing the cap in a tertiary cap receptacle. Basically, there's a process. These fill drain valves are, the way they're capped off and secured on a satellite is they're meant to never be accessed again right before launch. So the refueling port itself will be torqued closed, and then after that we'll put 2 different caps on top of the valve, and then those caps themselves will be wired shut as well. So it's really a not friendly interface. It's non-cooperative. And here we're pulling out the EVR nozzle tool, or the ENT, and this is actually the fluid transfer tool itself. You'll see there's a hose attached to it. The tool goes ahead and it connects to the refueling valve. And once it threads on, it releases the valve to open up, and then we transfer fluid through the payload itself. And the RRM payload itself does have fluid transfer capability. So we're actually practicing transferring fluid out of RRM through the tool and back into RRM.
Okay, so like you mentioned, this is all being done in order to eventually service satellites that were built and made to never be serviced. So what are some of the activities it's going to be doing to kind of mimic tackling those challenges?
So that's a very good question. You know, the challenges being that these interfaces don't have with robotics. You're very used to using optical cues and large lead-ins to access something. You know, with a human hand, you're typically used to being compliant in yourself. You know, it's very easy to feel around and feel how something fits. With a robot, that's very difficult because the robot can't really sense the same way humans can. So the real challenge is making sure we design the tools correctly to access these interfaces, because we have no control how the interface was designed. It's already up there on, you know, hundreds of satellites, and the satellite designers don't want to change anything to accommodate us because we haven't proved we can service a satellite yet. So RRM is here trying to build experience, and we're trying to say, look, we can do it on these interfaces. These are just like interfaces on satellites that are already up in orbit. So it's kind of a test bed to prove that we have this kind of experience.
So really just kind of the first step in ensuring that you can convince others that such a process is even going to be possible.
Precisely.
Okay, well, walk us through a little bit of the activities going on today. I know they're checking out some of the tools. What are the exact specifications of what they're doing today?
Sure. This is a very exciting day because this is the first day that we actually access 3 of our tools and power on the tool cameras. So the 3 different tools today that we're checking out are the wire cutter tool, the safety cap tool, and the multifunction tool. And what we're going to do initially is SPDM will go up and grasp the 3 tools, power them on, make sure the tool cameras work. We'll pull them out of the bay. We'll do a visual inspection of them, and then we'll actually access. We'll use the torquer to command the tools and make sure all the tool modes work. And once we've checked out the tools, we'll proceed to use the multifunction tool to release. Basically, we have launch locks on some of the adapters, and we need to go ahead and we need to release all those launch locks so we're prepared to pull the adapters out. And then after that, we're going to use the wire cutter tool where we have a gas fittings panel, which is representative of different satellite interfaces. Not all satellites just need refueling. Some of them need gas coolant filled. Mm-hmm. And we have wires on some of those caps there that we use the wire cutter tool to cut the wires between 2 different T valves, and then there's a cap on there that we need to cut a wire on.
Okay. And so, like you said, today's exciting, but it's just kind of a checkout day. What about the next 2 days? Is that going to be, you're going to be cutting wires and actually transferring any fluid over the next few days, or what are the activities going to involve?
No, we won't be transferring fluid, unfortunately. That's a bit down the road, but you're correct. We will be cutting wires. We don't have a full set schedule for each of the next days. The idea is to press and see how much we can get done every day. Ideally, we'd like to get ahead. Today will be mostly just the free space checkouts of the tools, and then tomorrow we'll probably be releasing those launch locks I was talking about, and the final day would be cutting wires.
Okay. All right, very cool. Well, we're going to be following along with everything. And again, this is all being done by controllers here in Houston and back at Goddard, so it's all people down on the ground controlling this robot 220 miles up in the air. So very exciting stuff. Well, Alex, I want to thank you very much for being here with me today. Really appreciate the information, and we'll be following along.
Thank you so much for your time. And if there's one more thing I can throw in, it's not just controllers here, but we're also working with the Canadian Space Agency and MDA. So we have controllers up in Canada helping us as well.
Okay, because Canada heavily involved with all the robotic arms, pretty much producing them, all the ones that are on board the station.
Correct.
So, all right, very cool. International effort on the International Space Station, just like so many of the things are. All right, thank you, Alex.
Thank you.